solid my treasure key from this end to the other without touching the copper wire.
If you touch the motor, the fan will spin.
So let's keep it ready.
This way. Okay.
Start. Most of the people reach till here.
At that could you reach till here? Let's try. Reach till here, huh?
Thank you.
So this is a very challenging experiment which will keep you busy for hours. You can build it.
Third, insulators and conductors. Materials required are rubber, a simple pencil, electric cell, alligator clips, and a motor. This is a very simple experiment which tells us what all materials conduct electricity or which do not conduct. Here you can see is an insulator and a conductor. Here is a motor fixed with a fan, a 9-volt battery, and an alligator clips.
So
A motor fixed with a fan, alligator clips. This graphite leads to high resistance, whereas
So we have connected 2 wires from the motor and 2 wires from the switch. Now we have 2 wires simply. And now we have a graphite lead.
which leads to high resistance.
And when we plug the the motor works. That means this is a conductor.
This is called a conductor. What is a conductor? Material which allow the current to flow are called conductors. And the next is rubber, simple rubber.
So I connect to the rubber.
The motor doesn't work. This is called the insulator. It is the opposite of conductor, the material which do not allow the current to flow. It's also known as a bad conductor.
Now we have a pencil.
Simple pencil.
We connect. It doesn't glow.
It's also
it
known
doesn't
as
work.
insulator.
It's known as an insulator. The motor doesn't work.
The wooden part is called the insulator, the graphite part is called the conductor.
And now we have a whole chart of insulators and conductors. Actually, both of them are named by the silk weaver, Stephen Gray. He was just a silk weaver. He was not a scientist. But still he did great experiment and did a great donation for the electric physical world. Next project.
Solar power.
Solar power LED. So now we have connected a solar cell to a LED.
Materials required are solar cell.
Torch. Sorry, what did we don't have real solar electricity, so because there's a roof, so we have got a torch.
Artificial source, like a torch. And the torch falls on when the light falls on the solar LED, you can see a small glow.
Small green color. Green color.
We don't have natural solar, it's a sunlight, so we're using artificial.
So here you see
Artificial.
and next one is
Electromagnetic.
next one vinegar battery. Zehin.
Here you can see there's a container filled with a vinegar and a tape poked with a zinc and a copper. The zinc acts as a negative terminal, this copper acts as a positive terminal. As you can see, this vinegar is a partial acid. It contains 4% of acetic acid. Here there's a voltage meter, a digital multimeter,
And we have 2 wires coming out with insulated topping and conductive bottom. And this
the black one
conducts electricity.
the black one is the negative, the red one
So it produces up to 2 to 3 volts.
1 to 2 volts.
1 to 3 most. So by using 1000 vinegar batteries, we can use a toaster.
It's also an alternate source of electricity.
Yeah, so we can use a toaster. To light up a whole house, we need something like 5,000, 50,000 like that for a whole building. 1,000 for a toaster itself. The next one, a very interesting one, the windmill. So now we have constructed this windmill by using PVC pipes, a simple motor, a propeller, blades, 2 screws, alligator clips and copper wires.
Alligator clips as a jumper clips.
So we have connected the alligator clips to the 2 screws, not exactly to the wires.
You can see a handrail which connects wind energy.
And now we connect it to the multimeter. And now we put it into the volts.
Look, you can see the
From 2 to 5 volts. The more the wind 3 volts, the better. Like this one, look, it's one.
The more it spins, the more voltage it increases.
It comes up to 1.5, 1.6.
You can see it's increasing. The more it spins, the more voltage it increases.
Lemon battery.
Here you can see lemon is a citrus acid. By suspending 2 metals in an acid, it generates electricity.
So we connect 2 of these into the LED and the LED glows red color.
You get voltage from fuse. As you can see, there is a chart.
The chart is over there.
Apple, orange, carrot, banana.
That's what we have displayed. And the banana we can charge a PSP for 10 minutes.
But it should be in an exact spot. Only professionals know the exact spot. If you keep it in the wrong spot, then your PSP might go. You can also charge an iPhone, but not mobile. It needs much more electricity.
Now the next one is how to arrange the cells in an electric bulb. We are not going to show you the electric bulb because all fused up. As we can see, we have been running for 2 days. The bulb will be the rest.
Combination of cells
Cells or battery. We must not connect positive to positive or negative to negative. We must connect positive to negative like this. Then only the bulb will work. Like this. And now, if we connect like this, also it will work. Positive to negative.
So you can see on the cylindrical surface, there's a plus sign and a minus.
Like we can know where's the minus sign when there's a plus sign. Like plus. So most probably the plus sign will be bulged in the copper cap. Minus sign will be flat. So thank you for listening us. Please do not waste any means of electricity. Protect the environment. Now the new information and news about electricity. The latest update is you can produce electricity from waste. The waste which you throw away, you can produce electricity from it. And these all are posters and other electricity conductors, insulators, and protect the environment. Today we introduce our motto, green. Go green. Thank you.